Well, this is the last talk of the morning, and then probably it's a different approach. It's not based on the concrete results. It's not focusing on things that are doing in the project. It's more reflections and potential use and how the industry, not only the genetics, also the producers, could arrange all the huge information that are watching here because it's impressive. And then, well, it's perspective from the industry, you know? And then, well, Aqua is a small enterprise. It's a company that is founded in 2012, like a spin-off of the University of Compostela, the group of Paulino, the genetics group. And then more than 10 years since this, we are closing collaborators also. But we are involved in Work Package 7, that is dissemination and exploitation working group. And I think it's a good, this thing, the exploitation working group, because the farmers are the final users of these technologies, no? And then we are like a little company, but we are the bridge. We are sometimes a translator of the information that go to the academia to the different kind of companies, because it's not easy to, well, we have a lot of different companies, heterogenic productions, species, and not all the companies have the same knowledge, no? And then it's difficult to manage these things. That is the top of the research, but it's not easy to get to the farms. And then it's very important, I think, that we are genetic advisors of aquaculture companies. We use genetic technology, we develop markers, we develop SNP chips, but improving their own stock. So we do not produce selected fish. We try to help this. And then it's very important because, well, sometimes it's difficult to say, but well, it's a lot of information, a lot of things, but for the companies, it's the cost. Yeah? The cost, when you go to the company and say, well, you could do this, this, and this, and they say, well, how much it here, and what's the return? And it's very, very important that you have some improvements. Genetic analysis are tailor-made breeding programs. Sometimes they need, sometimes they don't need so much information. And well, we are working with tarbot, is the main species, where they have more information, but other different species like bream, bass, rainbow trout, and also the Senegal sole that is emerging now like a good product in Spain and also with other companies. And I think that it's also interesting species for the future. And then we take account of all the genomic resources that I have available in the different things, because we don't have our industrial projects. No, we generate new information, like you could see, but also we are very in contact with some other big projects, so Ethical Race, Feedfood, Medaid. Well, we have to pick up all the interesting things to move. But, well, it's very important to say that, well, some companies, if you have interest in growth, that is the first trait, well, you would make it family assimilation with some genotypes, microsatellites, or a few SNPs. A classic with a bloop, if it has good heritability, is okay. And for some companies, it's okay, and make it very, very profits, and then it's not, don't need more. But if you are interested in disease and resistant on other complex traits, well, we are moving for genomic selection like you see all these days. No? Well, for the genomic selection, it's more or less like this. You are very, well, you know everyone, but not all the companies say that that you have to phenotype and genotype high number of fishes. No, you have to put this the training populations that link it with the different traits that you want to improve, and then it's disease resistance, product quality, carcass yield, lipids, something like that, or also the genetic environment, no? The climate change, the temperature, how it's adapting. And then you have all your reproduction, the families, the identification, and then you have the reproduction of the breeders, but also this that is normally siblings or full sibs of the individuals to get the SNPs. Well, we have information for some disease like this, no? And this is the methodology that we know that it's good, and it's also functional, but we have to heterogeneous population, GWAS, functional genes, and also in the future, probably, sometimes it's legal or not, the use of gene editing, but the problem is the high genotyping cost and the complex operations for the producer. Yeah? It's not have a lot of slaughtering, because for measure the product quality or the disease resistance, you have to put a lot of individuals in the disease challenge, and they die. No? And then you pay a lot for the genotyping, and we have to get information, valuable information for them. And then GeneAqua, we are very close relationship with the producers. And then what's the problem? Well, the problem is the price sometimes. And then we are, we assume some of the things that they were listening this morning. You have more or less with 5 key. It's enough for the genomic selection. It's like this figure that Christina Cleary do from 2020. But also we are sometimes commercial chips, the Axiom, the 50C. Well, but for our aim, it's for create new multi-species SNP chip that we think that is better accuracy than the genotyping by sequencing, and then design cost-effective SNP chips. But like say the combine species in the same chip, but for different companies. No, we have different companies with different interests, for turbot, for bream, for brass, for rainbow trout, for Senegal sole, also for mollusks, also for shrimp, clam, mussel. Well, we have to make these things, and then we are doing more or less it's the Axiom, it's 60 keys, and then you put 5 key, 12 species. 12 species from different companies, and also with mammals, no? You could share the platform and then get more better prices, because it will have more volume. You only buy one type of chip, but you could use a lot of things. And then, well, we are also thinking for SNP chip panels with different density, only make the high density of the whole genome sequencing of the parents, the low, well, you have cost effective for the imputation. And we are also taking some enrichment of the genomic tools with specific SNP picking for QTLs, or also, well, taking account of the information of GWAS, genetic architecture. But it's tricky, because you have to test different species, different disease without previous information, no? And then it's not easy. And then we have to test if it's going well or not. And of course, not always the IPN success, no? Not always with a mass selection, all the things going well. You have to do genomic selection, and sometimes the company is the first question that you say, you could say more or less the same as IPN or not, no? Because it's a very nice information, but I think it's the first discovering, and then the people sometimes think that it's all the same, and it's not all the same, no? But we are linking with the producers, no? And then we are making all these informations and making all this new knowledge, but it's for using for the companies. And then we have, well, in the exploitation working group, we are in contact with different companies, and then it's more linked by the panel discussion probably, but by the reflections, the things that the companies think that we have to solve, or the things that we have to be working on. Because we have to focus the efforts on the things that the market value. And then, well, it's for alphabetic order, 3 companies of Spain. That is Cook, That is the Aquacultur. It's an integrated aquaculture group of producing sea bream and sea bass. More than 25 years, 20,000 tons of bass are bringing per year. The land-based hatchery, and more than 7 processes in all the Mediterranean. And then, it's have the research and development and the genetics center. And, it's not big, 500 employees. It's a lot of people living from this, no? And then, you have breeding programs, house managing from bream and bass, more or less 2010, 2080. But now for genomic selection in 2021 for bass, multi-trait, and disease resistant is one of the main things. And we have a lot of efforts, networking, and also three geneticists. That is not usual in all the companies, no, because it's probably good. And then it's involved in different projects that it's very nice because I think it is good to collaborate with research and companies to get the information. Well, and then the opinion of the bass and bream industry for the point of view of Culmarex, it's more or less the same. Developed cost-effective molecular tools. It's prohibitively the high genotyping cost. Educate or create reasonable expectations. No, when you first approach, we go them, and then how much, and then, they want to know exactly the long-term gains. That is not easy, but we have to be reasonable. No, not put the top on the tooth. And then also provide the industry with gold standards for phenotypic evaluations, but we were talking about phenotypics, but what is the phenotypic? It's day of, for including disease, it's the day of the daylight, or it's more another things of how to get the phenotypics. And this is one of two things that collaboration, research entities, and also public access to new knowledge that I think that is good. And then, from the Aqua Faang project, the company said they would probably very, very valuable genomic resource, and then genome referring, and also we had very, very nice to get all the information in November from the ensemble. And then the applications was complex this trait, functional data enriched, SNP panels for genome selection in sea bass with a new virus, nerve necrosis causal variants, and QTL markers of them with relevant functional genes. This is what they expect from the project. Ovapecies is another kind of company. It's also for the Spanish, but it's trout egg producer. Yeah, it's not a big company. They have one farm originally, but now 5 sites in the north of Spain. It's growing and learning and things, but it's the Europe's largest trout eggs producer. 460 million of embryonated eggs. They sell the eggs for the another companies. They produce only eggs with their fish, but they go to another farms to raise them. And then the main interest is have 2 different things. The egg quality, the egg production, because they have to produce a lot of eggs to sell, but also the fish health, and it is resistant in the place that they are growing. That is very, very difficult to get feedback from the other farms, but they have to put information. And then it's genomic selection, multi-trait breeding program, sustainability network, and also they are proud to participate in this kind of projects like Aqua Faang. And they, it's the same more or less. Cost-effective scenario, causal variants, the breeding program, and also disease-resistant reproductive for minimizing the quantity challenge per breeding cycle. No, because for the linkage disequilibrium, the things is within population, is not across population, across generations, and then it's a problem because they have to put efforts every round. No? And then it's, probably we could manage in a different way. And this is compromise for them. And also another big company, it's Stolze Farm, a leader producer of land-based turbot and sole, operation in 5 countries, Spain, France, Iceland, Norway, Portugal, sold in 30 countries, and then also 450 employees. That is a lot of people. And then, well, there are all the research and development, the complete breeding cycle, 2 hatcheries, 9 million juveniles, aquaculture that is serving sustainable sole and turbot for a lot of markets, 30 countries, and well, it's going that. And then what's expected from Aqua Faang? Well, because it's the knowledge, the identification of the causal variants, the regulatory elements, because now the main interest is growth, but also it's a disease, it's a parasite. And the parasites will not in this project, no, because we have viral and we have bacteria, mimics, but we don't have the parasite. But I think for the future also parasites are interesting. And well, the same disease resistance, reduce the current need, the infection challenge. And then well, we are working with the collaboration with the Paulino's team, the USC, and then apply the new information they generated in this project to enrich the functional information of the SNP and then refine, and also it's a cost-effective in the scenario, no? And then, well, it's more or less a summary because it's the same. They have different needs, but more or less cost-effective molecular tools because it's high genotyping cost, accurate prediction of genomic selection because they have to evaluate the invest risks, no? They have to put money and how it's the return, gold standard protocols for phenotypic evaluations, and also reduce the current of the infection challenge for costly and also for the animal welfare. No? You are slaughtering a lot of individuals, and I think it's better to get. And also with public access to the new knowledge and communication, research, and private companies. And I think that a lot of these things would be overlap with the Aqua Faang results. No? It's relevant for the industry. Yeah, of course, we have generally valuable genomic results, 60 species, more than 4,000 omics. Well, this is based on all the things that we are listening these years. But, well, it's functional annotation maps, genome maps, immune maps, well, and also the open accessing ensemble is very nice. Variant effect prediction, it's very, very important to get genetic variants overlapped with functional annotations, mapping QTLs, causing variants, exploiting the genome functional annotations, and, well, also the genomic elements for the virus and bacterials overlapping disease resistance, and also for the prioritization of SNPs. We have all these things in account to make enriched low-density SNP panels. That's a team now that is validating, and it's going well in the enriched SNPs, low density. And then also, which is very nice for the UVNN resistance in SIVAs and genomic prediction, or also identifying targets. But, well, it's a huge amount of information, but I think that we still need to study, validate, and test a lot of things. But GenAqua will use the Aqua Faang results to improve the knowledge about functional annotation and regulation to generate now tools. The new low-density SNP panels we are making now only based in MAF, in minimal frequency, in distribution of the genome, but now we have all the information for the future, prioritize SNPs linked with annotation information, because I think that is better. I think more or less five key. It's enough, but if you put this kind of SNPs, it's very, very, we suppose that it's more effective. And new multi-species is the same that I said. 4 species we have in the project, turbot, brown breeze, rainbow trout. And for Senegal sole, we have important for the future also. We're talking yesterday for the probably Aqua Faang 2.0, the compared genomics, also flatfish, and then we could share and spare the information with another two things. And then, well, for turbo data and also Senegal sole, it's very important to improve the reproduction. And also for use the new annotation info for the genomic tools, working on refine or fine mapping of the previous QTL knowledge for growth, sex determination, and disease resistant, that is Philasterides, is the ciliate, or also bacteria like Aeromonas. And then we are making efforts with the group of Diego to fine mapping of these things to get information that is close or not some functional variants or causal variants. For turbo body maps, yeah, is the sex differentiation. We have to have mature, non-mature, males, females, because the females have 20% more growth than the males, and then it's important also to get more accurate markers from the sex, and some genomic elements associated with viral and bacteria signals, because, well, I say, like, I think that Pierre and things talking about this, that's probably is not the same, no? So virus or bacteria, if you select from one, probably is a problem for another one. But we thought that we have regions and impacts on these disease-resistant phenotypes, no? These common genes, this inflammatory or something like this, that you have select more robust fish, no? But nobody based on a specific disease challenge, but then probably it's more robust. No, let's see. And also for the genetic architecture or GWAS, well, the Work Package 5, it's a very, very complex and expensive for the companies, but we have the good methodology and the venereal resistance that it's now testing if it's going well or not, and I think it's the mirror for another other disease. And as well, I put over there more or less like a take-home message for the panel discussion, no? Because have now reducing the genotyping cost, develop cost-effective molecular tools, accurate predictions and expecting medium long-term gains, reduce the current need to perform infectious challenge of slaughtering, because animal welfare are gold standard protocols that is released in the project also, and use information from other studies for the species level, because sometimes you go to the farm and they say, well, we have some study of French, we could use the same marker here. Well, it's not easy now, but if you have the causal variants of the annotation, would probably in the future we could see. And then, well, the Aqua Faang results, I think it's, of course, improve the knowledge about functional, but we have to create a lot of effort now because, well, the public's access to knowledge and work, a lot of people them collaborated because research entities and private companies, and also to the private companies in the staff invest in bioinformatics and genomics and quantitative profiles, because sometimes it's very, very hard to manage all these things. And then I think it's for the future in the companies of producers, they have to increase the number of these profile staff. And well, I think it's some reflections for the future for the panel. And well, thank you for your attention, and thank you all of the participants in the project for the huge effort and the amazing results.